Hello everyone, welcome to the channel. In this video, we will be covering a machine learning model from the FastAI tutorials. We will be also deploying it to Hugging Face and checking how it works on live. So first thing first, let me brief you what FastAI is. Let's start FastAI. So for those who don't know, FastAI is a library built on top of PyTorch, which deals with deep learning models. Out of the box, it supports 4 types of applications: Vision, Text, Tabular, and Collab. Collab is another name for recommendation systems. And all these 4 applications are based on high-level APIs. Now, there are 2 high-level APIs, Learner and Datablock. Learner is sort of a model and its entire workflow, including training the model, using it to predict the outputs, and multiple other helper or utility functions. Datablock is the data in a much more organized and pre-processed format, and we will take a look at both of these in this project. So let's get started. First, we'll be importing the FastAI library, fastai.vision.org. Import star. Next, we'll fetch the dataset, and there is a very cool method by the name of undata. Let me show you in FastAI folder. So it's a thin wrapper which helps us download the files from a particular URL, and it also uncompresses the data that's downloaded. So we'll use that. So path equals undata, and we're going to pass it one of the pet URLs. Pets URL. So once done, so this step will take some time because it is fetching from the remote repository. Now, the first time you do it, it will download the entire dataset locally, which means the next time you do it, it will just read from the local database. Next, so we'll wait till it finishes. In the meanwhile, we'll just print the path of the repository. So undata will extract and assign the folder directive to the path variable, and we'll hopefully see what the path variable looks like. Awesome. So we have one images folder and one annotations. We'll of course use the images one. Now the next method we're going to use is the get images file. So since this is a computer vision task that we're going to perform, we'll be using get image files, which gets the image files recursively from a folder. So let's use that. Files equals get image files, the path, and the images directory, which is the folder name. And then let us print the number of files that it's found. It is close to 7400. Next, let us see what the file names look like. One is Siamese 200, the other is Stafford Bull Terrier. A quick note: the image with the capital letter starting with the capital letter is a cat, and the image name starting with the small case letter is a dog. So we will be using this analogy to define a label function. Label function, which will take in the file name if and return us whether the file contains an uppercase, which means whether it's a cat or a dog. F of 0 is upper. Once done, we will now use one of the data loaders as we just discussed. It will be a image data loader. So it's a basic wraparound data loader, which is one of the 2 high-level APIs we just saw. It is not meant to be called directly. We have several factory methods. The one we are going to use is from name function. Since we are using a function, which is this label function, to predict whether the image is of a cat or a dog, and so we use this method and assign data loaders out of it. Now, what we need to pass is first path, where the record.data lies, and the files, which contains a list of all the files. Next is the label function, which we are going to use to predict whether it's a cat or not a cat. And then item transformation, TFLS, which we are going to use the resize one, which will take each item and then transform it into a 224 x 224 pixel size. Now, it may take a couple of seconds. Okay, it's done. Next, one of the most important, I believe, is this method .showBatch. Now, what it does, so this data loader is this sort of data that we are trying to train the model on. ShowBatch helps us visualize what the data looks like before it is being fed into the model to train it. So as you can see, since it is a image data loader or a vision task, hence it is showing us an image, and on the top of it the label that the model inherently uses. Since it says false, it means it's a dog. That's it. Now on the third image is true, which means it's a cat. Now once this is done, we will use a vision learner, which is again similar to how this image data loader is. Similarly, we have vision learner, which again is built on top of learners. We need to pass in a couple of parameters. The most important one being DLS, which is data loaders, which is in simple terms of data. And second is the architecture. Now, architecture means predefined models, if any, and hopefully there are. So we'll be using learn equals vision learner, the data, Next, we have a bunch of models that we can use, and since, as I mentioned, it's built on top of PyTorch, hence it supports all of the models that PyTorch supports. So it's a list of ResNet models, and we will be using ResNet 34, so you just need to copy the name, pass it here, that's it. Apart from this, we need to pass in a matrix, for which we'll be using error rate. And finally, we will fine-tune the model. While it must take some time, let me change the runtime and switch to a GPU in runtime so that it saves our time. Okay, so while it's processing, let me give you a brief of what fine-tune does. So as you might have already noticed, we are using the ResNet 34 model, which is a model built on top of all the images from ImageNet. It's a good model which comes out of the box with all of the images being trained on. Now, we don't need all of the images, we just need the cat and a dog classifier for this task at least. And hence we will fine-tune the model, which means we have a pre-trained model and we are going to train it on our custom data so that whenever we use the model to predict a use case, it gives much more relevant results as compared to what it would if we use a generic model like ResNet 34. Okay, so it is showing the batch. So for saving the time, I've just used fine-tuning 1, which is the number of epochs that we want to train it. Or you can, of course, increase or decrease. We will take a look at how to find the learning rate. If you want to pass it, you have the option to do so as well. Now, let me quickly show you what other parameters it supports. This is a fine-tuned model. We have the number of epochs, which I've passed in our case 1, base learning rate, freeze epochs, so on and so forth. You can have a look. I'll share all the docs in the description below. So it will take some time, about 30-40 seconds. So we'll jump right after the fine-tuning is done. Okay, we are back now and the fine-tuning is done. Now let us use this model to predict one of our files. So let me bring the file name and one of the files, and then use the model to predict one of the files. As you can see, the name of the file was UR, which starts with small letter, which means it's a dog, and the model classified is false, which means it's not a dog, not a cat. Okay, so let us see some more results that the model will train on. I'm not sure results. I think this is it. Well, let me show you the dogs to show results. In parts in maximum number of samples you want to see. By default, it shows 9, and hence, yeah, we should see a 3x3 grid. This is a dog, false is the prediction, and false is the actual variable as well. Alright, now let us do a final thing and deploy this model, since we already saw that learn is inherently the model that we're going to use. So let us do learn.export, where with the file system, let me put it on content and classify dog at.quickly. Apart from this, if you download directly from the Google Colab, I found it pretty slow. Hence, I'll be exporting or moving the model from the Google Colab to my Google Drive and download it from there. So to do it, just import shuttle and then shuttle.copy the content drive, my drive, and models. Remember that the models should be a folder which will be presenting a root directory of the drive. So let me run it. SHUTIL shuttle. Okay, let me give the path from which it has to pick up the file. Now it should work. So this was the models folder, and I did it right now. So maybe in 30 seconds or thereabout, I should see a model file by the name of classifier.cat.pd. Yep, here it is. So I'll download it, and meanwhile start up the Hugging Face where we are going to deploy this model. So this is the Hugging Face website. You need to have a logged in user credential. I'm already logged in. I'll go to create new space. Let's just name it at M03. License second with any, but leading to MIT. Download it, that's fine. I'll use Gradio. And the hardware would be a free one, of course. Public, create space. Alright. So I'm in my Gradio space or Hugging Face space. I'll be using Gradio as a web UI interface. We'll come on to it in a second. So let me open VS Code, which is the IDE I am going to use. Clone the repo. Alright. Let me add an app.py file. Py save here and do a bit push. I need to authenticate. Yeah. Let me grab the password. Pushed, which means it is starting off to build dummy template. So while it is building off, let me show you the changes we need to do. First, we have already downloaded the model, and so we'll just go over here into our downloads and the model here, that it is classified dog cat pickle. Next, we are going to load this pickle file. For that, we need to import FastAI. Again, similar from FastAI.vision.all.star, and FastAI would not be present by default, hence will require requirements.txt file with FastAI. Let's save it. Next, we need to load the learner, which comes out of the box, load learner, and the name of the meta path. Fine. And let's name it learn. Give the name to fn. Meanwhile, app is started executing. Let us see what it looks like. So it's a dummy template, as you see. I'll just type in anything, n03, and it says hi, n03 hello. So let me move over to here. Okay, so I've loaded the model into the repository, into the code. Next, if you remember, we used label function to classify whether it's a dog or a cat, hence we need to use it again. That is also done. Right. Next, since we are not passing a name, we're passing an image. And the reason we're passing an image is because we want to give the user ability to upload an image, for which we will have gr.image shape equals 192 cross 192. We are hard coding the input, which means that whatever shape and size of the image the user sends us, we are going to reshape it to 192 cross 192. And this is the input we require. The output would be a label, so gr.label. That should be good. So this is the image input, this is the label, and we have put in label as an output, so it will go as an output, image in the input, and this is a function that will be mapping our inputs to the outputs. And interface is basically the web UI interface. Let me show you what do I mean by it. This is the interface reduced mean level, high level class, which helps us to create a web-based GUI. And we have used this launch method, which launches a simple web server for this. Awesome. Since we have done with this, we have added requirements file. I think it should be good to go. Let us clear it out to a git add, git commit, and git push. Classify model, commit, git push. Okay, since the model is quite bulky, around 100 megabytes, 89 to 100 megabytes, it might take seconds. Meanwhile, let us go and check how it's performing. This is the image component. You can pass in a numpy array, pil.image, as well as a string which refers to the file that we want. These are the bunch of parameters it supports. And similarly for label, here it is. This is what the output would look like. And these are some of the attributes that it supports. One more thing to note, that our interface in the launch part, it does support authorization. So if you want to have that login screen, it supports that out of the box. I think we have done a commit. It's already done. Next, we'll wait for it to build, and then we will test our application. Let's hope there are no errors. Okay, fine. Let us wait for some time, and I'll skip the part to where it starts running. Okay, now we are back. You can see the running. Let us see what the app looks like. So an input image and an output label. Let's go over to Google and let's check some dog images. Let's take this. paste, check if it's a cat or dog. It says error. Yes, I think we missed something. Okay, it just says hello. We missed this part. So we want to use our learner to predict the image. It will provide us with predictions, indexes, and the probabilities. And it will provide us probabilities with the categories which it supports. Currently, we are having dog and cat. I'm going to return it to the label, and the label expects a dictionary formed in zip categories that supports, and all the probabilities. And I'm just mapping all the probabilities to a float variable. We will save it. As simple as fix, commit, and push. Let's push it now. Done. Let's wait for it to build and then we'll check it again. Awesome. Now it started running. Let me refresh. Now let me take the image again. Submit it. Okay, now it says dog. That's a good step first. Let me check again with another image. Again it says dog. It's great. And let's check some cat images. Let's take this. Cat. What about this? Cartoon image, huh? Let dog. Even the model is confused, seems like. So that's it in this section. In the next section, we will look at how to classify dogs and cats, different breeds, using the same model, and we will extend the model further. Thanks for watching.